when the universe first started, there wasn't actually much in it. It was pretty much just hydrogen atoms floating around, and you might think, what is there to look at? How do you observe the universe when there's no stars or galaxies, which are the things that we normally look at with telescopes. And so you can actually do that. You can look directly at the hydrogen atoms if you have a radio telescope that operates at the right frequencies.
So we use a radio telescope in the Murchison region of the Western Australian desert called the Murchison Wide Field Array. And that's a telescope that sort of had these little spider antennas on the ground. It's a little bit like picking up TV with a TV antenna, but there's a lot of them. And what they do is they allow us to reconstruct what's happening in the early universe, and in particular what's happening around the stars.
So I actually use the largest available optical telescope in the world currently, which is about the size of an entire building. It's about 10 meters in diameter, so it's huge. And the reason we need such big telescopes is because the objects that I'm trying to look at, they're very, very far away. So they are very faint and hard to observe.
I love to push the observational boundary. I love to observe things that we don't have a complete theory for yet. So my most recent exciting discovery is that I discovered and confirmed the most ancient spiral galaxy.
My research is using simulations to try and study these galaxies. So I use some of Australia's biggest supercomputers and run simulations of early galaxy formation, and then compare these to observations taken from big, powerful space-based telescopes like the Hubble Space Telescope.
Australia has been building instruments that can look at 400 stars at once. In the olden days, you looked at star by star, and you literally the telescope would go over here, over there, one star at a time. Today, it's 400 fibers, optical fibers. We use robots to position them on 400 stars, because each star pattern is different, so you have to have a robot that moves the optical fibers around.
Detecting the atomic hydrogen is difficult because the emission is very, very faint. And so you need very big telescopes, and Arecibo was the largest in the world.
So we've just started using a new telescope called ASCAP, the Australian SK Pathfinder. It's located in a really remote part of Western Australia, away from civilization and away from the kind of radio noise that drowns out the cosmic signals if you're close to a big city. And so this allows us to pick up really faint traces of hydrogen gas over a time span of several billion years.